The global energy grid is moving away from fossil fuels at a rate that is outpacing the development of reliable, carbon-free baseload capacity. To prevent widespread power failures during this shift, we need a source of electricity that runs 24 hours a day, regardless of weather conditions. Historically, traditional nuclear power was intended to fill that role, but as plants grew in size, they became highly customized, requiring years of on-site construction and billions in capital. The sheer scale of these projects made them impossible to finance. As older plants retire, they are being replaced by wind and solar. These are vital for decarbonization, but they are intermittent by nature. When the wind dies down or the sun sets, the power supply drops. Without a stable backup running underneath them, the grid becomes vulnerable to sudden blackouts during periods of high demand. Engineers are now pivoting away from the idea that nuclear plants need to be massive to be efficient. The emerging solution is to shrink the technology into small modular reactors, or SMRs. Moving toward a manufactured scale allows nuclear plants to be deployed as standardized units. This provides the responsive backup required to keep a renewable heavy grid operational. Let's break down the mechanics, starting with the small. We are talking about reactors that generate 300 megawatts or less, roughly a tenth of the output of a traditional plant. Because of its small size, an SMR uses gravity and natural convection to circulate cooling water, rather than complex pumps. This creates passive safety. If external power is lost, the reactor shuts down automatically. Physics take over, cooling the core indefinitely without human intervention. Then there is the modular aspect. Rather than building a unique facility on site, the core components are produced on a factory assembly line. These self-contained modules are uniquely designed to be shipped over standard road networks directly to the installation site. This shift to factory manufacturing can reduce deployment timelines from a decade to approximately 3 years. Finally, the reactor. Despite the smaller footprint, these units still utilize proven nuclear fission technology to generate high-density energy. By shrinking the physical footprint, the industry avoids the two biggest hurdles of traditional nuclear. The physics eliminate the risk of complex meltdowns, and the factory production model provides a predictable path for construction costs. To see the real value of an SMR, we have to look at its role within the broader electrical grid. Modern grids require load following. When clouds block solar farms or wind drops, an SMR module instantly ramps up its output to fill the energy deficit. This creates a continuous power supply, solving renewable intermittency without burning fossil fuels to maintain stability. These reactors also offer black start capabilities. If a severe event causes a total regional blackout, a single SMR module can restart a dead grid independently, providing the initial power needed to bring other systems back online. Because SMRs are compact and passively safe, they skip massive land acquisitions. They fit where large reactors cannot. This makes them ideal for coal-to-nuclear repowering. A utility can install an SMR at a retiring coal plant, reusing the existing transmission lines and infrastructure while preserving local energy jobs. SMRs do not compete with wind and solar power. They provide the steady, flexible reliability required for a fully decarbonized grid to function in the real world. Given the history of the nuclear industry, it is fair to ask if this technology is still just a theoretical concept. This timeline shows the projected deployment stages for various SMR designs through 2050. Currently, there are over 100 different designs in active development, and several have already reached the operational phase. In China, the HTR-PM reactor is already operational and connected to the commercial grid. We are also seeing the deployment of mobile nuclear power. The academic Lomonosov is a floating barge equipped with 2 reactors, which can be towed to remote Arctic regions to provide power where fixed infrastructure is impossible to build. Momentum is building in the West as well. Projects like the Hermes reactor are moving into the build phase, and NuScale's design has officially received certification from the U.S. Nuclear Regulatory Commission. This versatility is opening up new applications, from powering localized microgrids and remote mining sites to meeting the massive constant energy demands of AI data centers. By the 2030s, the energy landscape will likely shift toward a decentralized, resilient system. Factory-built nuclear reactors will provide the flexible, clean energy needed to sustain a modernized grid. Do you think SMRs are the final piece of the clean energy puzzle? Let me know your thoughts in the comments. If you enjoyed this deep dive, like the video and subscribe for more.